All right, chemistry, let's take a look at your worksheet for chapter 11, section 4, talking about effusion and diffusion. First up, number 1, list all of the following gases in order of rate of effusion from lowest to highest. Assume all gases are at the same temperature and pressure. So this means, same temperature and pressure, this means that the kinetic energies of both, on average, are equal. And because Ke is equal to 1/2 mv squared, but the kinetic energies of all these gases are the same, that means that they're 1/2 mv squareds. Oh my gosh, what am I doing here? That their 1/2 mv squareds are also the same. So that means we are being asked about the order of their rate of effusion. That has to do with their velocity. The faster they go, the higher the rate of effusion. The slower they go, the lower the rate of effusion. And so since we're really wondering what's going to make these velocities larger or smaller, we have to look at this m value, the mass. The larger the mass, lower the velocity. Smaller the mass, larger the velocity. So another way, in terms of what we're actually going to do here, we're being asked to calculate the masses of each of these 4 gases and then order them from heaviest to lightest, right? Because the heaviest will go slowest, the lightest will go fastest. That's what we're actually assessing here for number 1. So looking at the periodic table, I just see that helium is 4.0 grams per mole. Looking at the periodic table, I just see that xenon is pretty darn heavy. Looking at the periodic table, I see that chlorine is 35.45, but there are 2 of them because it's Cl2. That's 70.9 grams per mole. And then mass of 1 chlorine and 1 hydrogen, 36.46. So what we're being asked to do here is rank these from heaviest, which would result in the lowest speed, to the lightest, which would result in the highest speed. So what's the heaviest? The number 1 heaviest thing here is xenon, so we're going to start with B. Okay, so I already counted for that. The next heaviest is Cl2, which is D. Okay, so I've already counted that. The next heaviest is HCl, so that's C. So, last in line, A. Right? Again, so we have to make sure that we understand what we're being asked to actually do here, and understanding what we're actually studying in section 4 is really going to help you do that. Remember that rate of diffusion has to do with the velocity, the speed at which those gases are moving. Part B, explain why you put the gases in the order above. Refer to the kinetic molecular theory to explain your to support your explanation. Well, all gases at the same temperature have the same average kinetic energy. Right? One particular molecule might have more kinetic energy, one particular molecule might have less kinetic energy, but if you average them all together, they will be the same. So because of that fact, right, therefore, heavier molecules have slower average speeds. Graham's law, which is what we want to be using, Graham's law states that molecular speeds vary, how do they vary? Inversely with the square roots of their molar masses. Thus, the gases are ranked from heaviest to lightest in terms of molar mass.